Okay, good morning, students. So today we will learn how to solve the numericals of a refrigeration process. Okay, and here I am going to explain you about how to solve the numerical and what are the steps to remember to solve the numericals on refrigeration. First point, what you need to understand here is what type of condition he has given in the cycle. Step number one, keep in mind what is the condition at input to the compressor. Input to compressor or output of compressor. This is the first point you need to remember to solve any numericals on refrigeration. The first point is input to the compressor. In this condition, in this today lecture, I have taken input to the compressor is in wet condition. Here is a wet. Okay, and output of the condenser, it is dry. The point number two is on dry line, that is vapor line. So this condition I will call it as dry. Okay, in the question paper will clearly mention that the output of the compressor, the refrigerant is in dry condition. Then this is the TS diagram you need to draw. And point number two on the pH diagram, it should lie on the vapor line or dry line. Okay, either he will give input to the compressor or output of the compressor. Here input to the compressor is wet condition. Why I'm using the word wet is it is between these two lines. The point number one point lies between liquid line and vapor line. So in this region, if anywhere it is there, it is wet. Similarly, point number four is also wet condition. Point number two is not wet because it is perfectly located on vapor line. And similarly, point number three is not wet or not dry. It is purely liquid condition. Okay, because point three is located on liquid line. So first, how to calculate COP? COP formula is refrigerating effect divided by work done on the compressor. So point 1 to 2. Point 1 is input to the compressor and point 2 is output or outlet of compressor. So 1 to 2 is compression process. Work is done on the compressor during 1 to 2 process. So keep in mind 1 to 2. So 1 is enthalpy at point number 1, that is H1. Okay, and point number 4 is H4. So 4 to 1 is refrigerating effect. What you call 4 to 1? It is a refrigerating effect, means amount of heat absorbed by the refrigerator from the cabin. Okay, that is called as evaporator process. Evaporating. So that is T1 is T4. Both are same here in the temperature TS diagram. Both are same. Here it is T3 is equal to T2. Okay. Now our aim is to find H1. So H1 is dry or wet? H1 is wet condition. And how to take the value of H1, H4, H2, I will explain in detail. Not to worry. Remember this formula. COP is equal to refrigerating effect divided by work done on the compressor. Compressor process is 1 to 2. Okay. So compressor process is here 1 to 2. Work done is on the compressor 1 to 2. And now, dear students, you can ask a question, sir, why you are not written H1 minus H2? Why you have written H2 minus H1 for the compressor? The reason simple is always you take highest enthalpy first. Here, if you take enthalpy, this is x-axis. If you take the value of H1 on the x-axis, H1 is less than H2. If you take from 0 origin here. So always you take highest enthalpy minus lowest enthalpy. So I will not consider this. Now our aim is to find out H1, H2 and H4. And dear students, keep in mind H4 is also equal to H3 because look at the pH diagram here. I have written H3 is equal to H4. So same formula I can write as COP is equal to H1 minus H3 divided by H2 minus H1. You can also write this formula. H1 is in wet condition, Now tell me, H2 is in which condition? H2 is in dry condition. H2 is in dry. H3 is in liquid condition because it is purely on liquid line. This is liquid line. This is vapor line. Both will meet at this point. Okay. So now I will show you how to take the values. Okay. First step, you have identified the condition. Very good. The next step, what we need to do here is, let me tell you, the second step important is identify the type of refrigerator or refrigerant, otherwise it is VCR or VAR. So identify, second point is type of refrigerant. I will tell you here and I will write step 2, identify, and this will be given in the given statement of the numerical. Identify type of refrigerant, that is working fluid, which refrigerant they are using, whether it is ammonia or freon, which refrigerant they are using, we need to write refrigerant or freon. In the question paper they will be given freon 12, 21, 22, ammonia, carbon dioxide, etc. Okay, first step is identify what is the condition in the compressor. Second step is identify type of refrigerant, and third step is note down the value of H1, H2, H3 from data handbook, and I will tell you simple method how to refer the data handbook. That is step number 3. And substitute fourth formula, substitute in the SCOP equation, that is H1 minus H4 divided by H2 minus H1, or else H1 minus H3 divided by H2 minus H1. Here you need to calculate H1, H2, H3. Some values you will get directly from data handbook, some values you will not be getting directly. You will be calculating using some additional formulas. Okay, first step is I have identified the condition. Okay, now assume that I will take I will assume maybe for the given condition it is 12. Okay, I will open the sheet. Okay, let me open the sheet now. Yes, it is here. Okay. Here in the thermodynamic data handbook, first go to content sheet. You should go to content sheet. You can refer any thermodynamic data handbook, no issues. Okay. In the content sheet, first you identify what type of refrigerants he has given, whether saturated, freon 22, freon 12, 11, 21, 13. So what type of refrigerant he has given, you need to identify. For example, given we will take it as freon 12. So go to freon 12, page number 34. If it is a 22 is given in the problem, go to page number 28. So I will go to 34. Here it is ammonia values. Continued ammonia. Let me go to page number 34. That is freon 12. Freon 12 technical name is dichloromethane. Okay, dichloromethane is freon 12 technical name. Okay, so next I will go to temperatures. Let us assume that what are the temperatures we'll take for the given condition. Let me take the evaporator temperature is, for example, how much should I take? Assume the condenser temperature, that is 2 to 3 is, I am just assuming it as 30 degrees Celsius. Okay, and this value will be given in the numerical. I am assuming it as 30 degrees Celsius, and the evaporator, the refrigerating effect process temperature, I am just assuming it as minus 10 degrees Celsius. Okay, so this is a given condition. The condenser temperature is 30 degrees Celsius, and evaporator or cabin temperature, I am assuming it as 10 degree Celsius. Okay, so T3, T2 is 30 degree, T1, T4 is, take it as minus 10 degrees Celsius. Okay, next point. Now I will go to the next step here. So which is the temperature he has given? Minus 10 and 30 degrees Celsius. And dear students, here identify H1 or H3. First you will calculate H1. Okay, H1 is related to minus 10 or which temperature? 30 degrees Celsius or minus 10 degrees Celsius, because H1 is related to condenser or evaporator. First you need to identify that condition. So H1, where is the point H1? H1 is here. Okay, let me erase all these points so that you will understand better. I will need some space to write here. Okay, next, this is x-axis, that is entropy. Now point number 1 is here. Point number 1 is related to minus 10 degree Celsius. Okay, point number 2 and 3 related to 30 degrees Celsius. So when you are calculating H1 value, you should consider minus 10 degree Celsius. So go to minus 10 degrees Celsius and note down the values of enthalpy. All enthalpies I will write. So go to enthalpy table, that is Freon 12. Freon 12, it is ammonia, and here it is Freon 12. Here is they have given. So go to 12, and where is minus 10 degree? Yes, here is a minus 10 degrees Celsius, as you can see here on the screen. So minus 10 degrees Celsius, note down the value of enthalpies. Which enthalpies you need to note down? Here is the enthalpy column, HF value, HFG value, and as well as HG value. So write all these values at minus 10. So I will write 26.851, that is HF, 156.201, that is HFG, 183.058, that is HG value. Okay, I will write here on the screen HG, HF, and HFG value. So H1 points. First I will write HF1. Why I'm writing HF1? Because I'm writing at minus 10 degrees Celsius at point 1 or 4.1. HF1 I am writing at minus 10, that is 26.85. These are the values, 26.85. This is at minus 10. Okay, in this row, 26.85. Next is 156.207. Let me write those values. So HFG at point 1, 156.2. Similarly, I will write HG value, that is also 183. Okay. Now this is at minus 10 degrees Celsius. So now, but I need H1. What is the basic formula to calculate H1? H1 is equal to HF1 plus X into HFG1. And dear students, always remember X is nothing dryness fraction. Dryness fraction will be always multiply with HFG. Okay, if it is in wet condition. Okay, wet means X value is less than 1 and greater than 0. We don't know how much it is. It may be 0.8, 0.5, 0.6, 0.9, whatever may be. If it is a dry, X is equal to 1. If it is wet, we don't know the value, but it lies between 0 to 1. And if it is liquid, X is equal to 0. This is for liquid condition, this is for dry condition, and for between these two, that is for wet condition. Here point number 1 is in wet condition. I need to find out first X value at point number 1. Okay, if point number 1 is on vapor line, if assume the point number 1 is here, then X is equal to 1 at point 1. For example, if I ask you to write X2 value, X2 directly you can write 1 because point number 2 is lies on vapor line. Okay, point number 2 is lying on vapor line. So to calculate XO, one more step you need to remember. That is simple step again. It is not complicated. So S1, that is entropy values, you need to note down. S1 at 0.1, SF1 plus X SFG1. This should be equal to S2. Why, sir, you are writing this equation? Please look at the screen now. In the TS diagram, point number 1, exactly point number 2, both are, it is vertical line. If you draw values at entropy, S1 is equal to S2, because 1 to 2 is isentropic compression process. For isentropic compression process, entropy is constant. Okay, so that value I will write here. S1 is equal to S2. That is the reason I have written S1 is equal to S2, because 1 to 2 is isentropic compression process. So what is isentropic? Entropy remains constant. ENTROP, entropy remains constant. So such process is for isentropic process. Now you need to take on SF1 and as well as SFG1. So SF1, again it is at minus 10 degrees Celsius, because point number 1 is minus 10 degrees Celsius. Point number 2 is at 30 degrees Celsius. Okay, so point number 1, again at minus 10, I will note down SF1. Go to the steam table, thermodynamic data handbook. Where is it minus 10? It is here. And these three values, three columns are entropy values: 0.01079, 0.5936, 0.7014. First, I will write SF values. SF1, directly I will substitute here 0.108. This is from thermodynamic data handbook at minus 10 degrees Celsius. That is for Freon 12. Keep in mind, for Freon 12. And properties will change for different refrigerants. X, I don't know, write as it is. SFG 0.593 is equal to, now S2. S2 is related to which temperature? Condenser temperature, that is 30 degrees Celsius. So go to S2 and note down the value here at plus 30 degrees Celsius. Where is 30 degree? Here is a 30 degree, first column. 30 degrees Celsius. The second row is 30 degree. Note down last value 0.6848. The column number 11 value you need to write. You can ask a question, why you are writing only the last SG value? Why you are not writing the SF and SFG? The reason is very easy. The answer for this question is because point number 2 is on dry line. So when any point lies on dry line, directly we'll write the value of gas, because it is purely gas. If you are writing the values at point number 2, enthalpy value, that is Hg at point 2, directly you can write, because it is not wet condition, it is purely dry condition. So here I am writing an entropy at point 2. So directly I will write S2 as Sg value. Sg value I will consider it as S2 because it is dry. If it is in wet condition, again I need to write the similar formula. Such formula I need to write. So S2 value at 30 degrees Celsius, that is Sg value is 0.684. So here this value you know, this value you know, this value you know, only unknown is X. So calculate X, that I will get as 0.97. Okay, if you have a calculator, you calculate and cross check the answers. So X is nothing but dryness fraction at point number 1, that is 0.97. This value I will substitute in H1 equation here. So H1, let me take different color. H1 is equal to, HF1 is 26.85 plus X you have calculated just now 0.97. HFG is 156.2. So now substitute in the calculator, and H1 value you will get it as 178. Approximately you are getting 178.36 kilojoule per kg. Okay. Now H1 you have calculated. H1 is enthalpy at first point. What is first point? Enthalpy at first point is input to the compressor. Input to compressor. Enthalpy at inlet of the compressor or inlet or input. Okay. Enthalpy at inlet of the compressor is H1. Okay. Now go to COP formula. What is COP formula? H1 minus H3. H1 you have calculated. Now our aim is to find out H2. Will come in sequential order. H1, H2, H3. So point number 2, H2 we need to find out. And you can get this value easily because point number 2 is perfectly on vapor line. So directly I will write Hg at point number 2. Okay, Hg value, I will consider it as enthalpy value at point 2. So point number 2 is related to condenser or evaporator? It is related to condenser. So condenser pressure is how much he has given? 30 degrees Celsius. So go to 30 degrees Celsius, rho, there go to enthalpy value, Hg value, that is considered as H2. So let me go to the table, H2 here. Okay, it is freon 12 or not? Yes, here it is a freon 12, table B3, saturated freon 12. Go to temperature 30 degrees Celsius in the first column. Here is a first row is 25, second row is 30. At 30 degrees Celsius, go to 8th column. 6th column is HF value, 7th column is HFG value, 8th column is directly I will write Hg value. Why I am writing Hg? Because point 2 is on vapor line. So no need to calculate HF and HFG once again. So 199.475 is the value of Hg2. I will write here H2. I will consider at Hg2 at 30 degrees Celsius condenser pressure, condenser temperature 30 degree. So 199.47 kilojoule per kg. Okay. So H1, H2, both you have calculated now. Now left is H3 in the formula COP, H1 minus H3 divided by H2 minus H1. H1 you have calculated, H2 also you have calculated, and now your aim is to calculate value of H3. Now first identify H3 is on dry line or on liquid line. Okay, so it is on point number 3 is here. Point number 3 is on liquid line. Here is a liquid line. Point number 3 on the liquid line. So if you are writing any values on the liquid line, now directly you can write only HF value. HF is related to liquid. F stands for fluid or liquid. Okay, just to remember like this. HFG is in middle between these two. If you are writing any value of enthalpy, that I will write HFG. And if you are writing the value of enthalpy on vapor line, that is Hg directly. So point number 3 is related to what line? Vapor line, liquid line. So directly you can write HF. Here it is H2. Point number 2 is vapor line. Point number 1 is wet. Understood? Okay. Even point number 4 is also wet. Now what I do is I will go to, let me highlight all the points here once again. So point number 3 is wet. Point number 2 is dry. Point number 1 is wet. Point number 4 is again it is wet. Point number 3 is liquid condition. Okay, let me highlight COP formula. Finally we need to substitute here in this equation. Okay, so go to the next H3. H3 is related to which temperature? Condenser temperature. How much is it? Is 30 degrees Celsius. So let me highlight the 30 degrees Celsius also. 30 degrees Celsius. Where is one more minus 10 degrees Celsius? Minus 10 degrees Celsius is condenser temperature. Okay. Go to 30 degrees Celsius. Directly you write HF value, only HF value. Not necessary to write again HF plus X into SFG, because point 3 is purely located on liquid line. liquid line. That is HF is sufficient. So I will go to the particular step where we stopped. Yeah, we are here. Now I need to write it as, let me take the new page. Okay. So if you have a thermodynamic data handbook with you and you write HF value, no issues, directly write. Okay. So I'm writing H3. H3 is equal to HF. Okay. At what pressure? At temperature 30 degrees Celsius, because 0.3 is related to condenser. Okay. Condenser temperature. Pressure will be given or temperature will be given. Anyone will be given in the numerical. Okay. So if the pressure is given, same formula, same pressure table you need to refer. H3 is equal to HF at 0.3. How much is the value? At 30, 64.53. I will show you in the data handbook page, kilojoule per kg. Let me go to here, 30 degree. So column number 2 is related to pressure. Column number 6 is related to HF. Column number 7 is HFG. Column number 8 is HG. That is what here it is given. It is there on the top, 6, 7, 8. Okay, 6 is HF, 7 is HFG, 8 is HG. Similarly, S stands for entropy. Entropy of fluid, that is liquid. Entropy of the wet condition, SFG. Entropy of dry, that is gas. So column number 6 we need at 30 degrees Celsius. Go to 30 degrees Celsius. That is column number 6 is 64.5. That I have written here. Now our aim is to find and substitute all the values in the COP equation. H1 minus H3 divided by H2 minus H1. We have calculated H1, H2 and H3. Substitute all the values so we can calculate the enthalpy easily. So these are the some steps. 199. I will write all the values. Okay. H1 is 178.36. And keep in mind, you should get COP always greater than 1. COP for this numerical, for these values, I will get it as 5.3. Okay. So these are the simple steps. First, I will repeat it again. Okay, we'll glance. First step, what we need to do, identify the condition of the compressor, condition of the refrigerant in the compressor. Inlet to compressor, at the inlet to the compressor, what is the type, whether it is wet or dry. If it is wet, you look at point number 1 between saturated liquid and saturated vapor line, here, somewhere here. If sometimes we will give inlet to the compressor is dry, in that case, the point number 1, the inlet point should be on vapor line. Okay. In that case, after that, you have to draw one vertical line. Simple. Draw one vertical line like this. For first case, it will touch to the vapor line. For the second case, when it is dry, it will go towards the right side. Point number 2 will be somewhere here. Second step is identify which type of refrigerant is given, whether freon 22, 21, 12, ammonia, carbon dioxide, what type of different types we may given in the numerical. Okay. Third step is go to the thermodynamic data handbook and identify and take the values. Okay. Go to first index table. In index tables, you will be finding all the values here in the contents index or contents table. You will find all the values. Freon 12 is B2. There is page number 28, 12, 11, 21, 114, 13, carbon dioxide, all values. Go to respective page number. For example, I have given a demo for freon 12. Go to page number 34. And this table is for ammonia. Okay. Go to page number 34. Here it is for freon 12. Okay. Next, after that, once you identify the refrigerant, identify condenser and evaporator temperature. And this value will be given. Either temperature will be given or pressure will be given. The temperature is given, go to temperature tables. Pressure is given, pressure table. Condenser temperature will be always more, greater than evaporator. In the given numerical demo, I have taken 10 degrees Celsius is evaporator, 30 degrees Celsius is condenser. Once you note down the values, write the formula of COP and substitute the equation. These are the simple steps. Okay. So I will explain with another condition in the next video lecture. Okay. Thank you.